All right. Good morning, everybody. Good morning. Hello, attacker. Welcome to the stream today. Good morning. Good morning. Arceus, I feel like I haven't seen you in a while. I'm not saying anything about that. It's just good to see you, that's all. For all I know, you could be in the stream. Hi, Coda. All right, everybody. So it is 11:21 actually, so we do have to get started here. I think I'm only going to take one, maybe a day and a half for templates, so we do kind of got to get started here. Now, I did say I would go over using CodeGrade for the assignment, so I'm just going to show you how to do it and how it works roughly. And I'm going to do that for you right now, and we'll just see how it goes. I told my supervisor that I would give it a fair shot, so here we are doing it. So if you like it, good for you, and if you don't like it, I'm sorry. I'm here to work with you, so of course you can send me messages if you need. I'll try to help you out getting this resolved, whatever problems you may have with submitting it this way. So to start, I'm going to pretend to be one of you guys. All right. And here you can see all of the assignments that you have to do. Notice that I've put the comprehension questions here. So instead of submitting them as text files, you can just type them in on Web Campus and get the answers that way. Now, this virtuals assignment, this is how it works. So if you click on it, you'll notice here there's a button to tell you to load it in a new window. So if I open this, it should look like this. For you guys, this is what you should see. All right, let me see if I can even make it larger. Yeah, so this is what you should see. And so you can check your previous submissions here, which I'll do in a moment. You can upload files, and you can check my rubric. So let's look at the rubric. And this is how I've set it up. So it's going to test it's going to test the three outputs. It's going to test it with puzzle 1. It's going to test it with puzzle 2, and it's going to test it with puzzle 3. You can see where points are allocated here. And then I have a little bit here that's going to check your memory usage. If any memory problems exist in your program, you're going to lose this point. But if your program is clean of memory leaks, you will get this point. I also guess this will only work if you match the output, but I think I did it with, I'll have to check. But if you match the program for output 1, I believe that this mem check will work just fine. And then finally, go away, please. I've written a script to kind of check your comments to make sure that you're putting some in there. So you'll get I guess 9 points. So this rubric translates to 90 total points. So I wrote the code for this comments checker. All right, it's mine. I made it. So it could even break based off of the programs you guys submit. If you mess up that file too much, that script might break. All right, so let me know if that happens. But I wrote this one. I didn't download it or anything. So notice that this is worth 90 points. That's because your comprehension questions are always worth 10 points. All right, your comp Qs are always worth 10 points. So this bit's worth 90. And so for every point you get here, that translates to 9 points. So you get 9 points for having decent comments. And so like I said, if you're having trouble with the comments checker, I'll show you. Do you remember at the beginning of the semester I showed you... Oh, I'm in the student's view. It doesn't matter. if you go to the syllabus and you look at it, you'll notice for some guaranteed points, you can include this little bit, right? I said for some guaranteed points. My script is equipped for that. All right, so if you put this directly, once again, directly, not like 20 lines above the function, but if you put it right above the function, you should get full points for this. So if you're having trouble with it, then yes. Now, Coda has a question here. So can we see if our outputs are perfect before we submit it? Well, so let me show you this. I know some of you already submitted it, and I know for a fact one of the codes actually worked. I mean, like the code was almost perfect, but you missed the points. Now, I'm still working on CodeGrade, okay? I'm trying to make this so it's not so cut and dry. Like, you match the output, you get the point. You don't match the output, you don't get the point. I'm trying to make it work this way because I'm still a noob, and I need to, like, take a class for this software. But what you can do is I'll show you when you submit it, this is what you have to pull in there. So I'm going to go find my solution. Should be here. Here it is. And so I'm going to upload the files that it's asking for. And I'll hit submit. And then it takes you to the auto test. So the first thing it's got to do is it's got to do some setup. So it's gonna load my script for your comments. It's also going to make sure Valgrind's installed. And then you'll see that it'll start to run here. Just a moment. So once it's ready, it's going to test your output with puzzle 1, and then it will test your output with puzzle 2. Yep, there it goes. Now it's trying number 3. Should give me, this one might just take a moment. Yep, and then it's going to check for Valgrind. It's taking just a moment. And then it's going to check your comments. And so as you do this, if you lose the point, for example here, you can compare the differences. You should be able to see it. So let me see. I guess since I got the points, let's see. There's an errors output. So here's where Valgrind puts its stuff. And I'm not sure, but you should be able to see the differences. So if the output doesn't match exactly, now I ignored all white spaces. That's the best I can do. But you should be able to click a tab here that says see differences. Maybe I can break this for you real quick. Let me break it. And let's see how it works. Ali asks, how many attempts? You have unlimited. You can just keep throwing the code at it if you want. Hopefully my Python script keeps working. But yeah, you can just keep throwing your code at it and it'll be fine. So I'm going to try to break my code here just a little bit. I'm going to mess up one output, and then I'm also going to forget to deallocate something. Let me see here. And I'll lose one of my comments. All right. So that should be fixed. All right, so I'm going to bring it back here. I just wanted to make sure no one saw that. And I'm going to try again. Oh, you can also see your code here, but I guess we've already, well, you didn't really see anything there. That's fine. So let me try it again with my new code. I can submit it. I'm clicking on a submit button. I don't think you can see it because my face is in the way, but there's a button down there you can click. So now I have to wait for it again, right? So it takes just a moment, and you should see that this passes. This one will fail. This one fails. The memory check fails, and then the comments will give me, I think, 80% or something. Oh, no. I guess it was okay with it. Oh, well. I guess that's good for you. So notice that this passed. Now, if you come look at this, here you can see the difference tab. And so if you click on the difference, Actually, there's no, well, there is a little bit of a difference. Down here, you notice that this blue stuff, that means I forgot to put a star on my pop. Now, I know that's annoying. I personally don't care if the output is exact or not. But if you're going to use this, we're going to use this software. So if you see this, just go put the star in your message, all right? Shouldn't take you more than 2 minutes. So that's where you can see it. Also, if you check the errors, it should say your val grind problem here. Yeah, so notice here that there's some bytes that are definitely lost. So that's kind of the tutorial of this. You know, if you missed the point, check the difference, see what the problem is. For the next one, I'm going to be working on doing something called unit testing so that you don't have to lose all the points if the outputs don't match. And honestly, if you're having some mega problems with this, some major problems, let me know so I can help you with it. All right. And one thing I will say, since this portion is output matching, I guess you could just like put a bunch of couts in your main. But for this assignment, I'll personally be checking for that. And in the next assignment, you won't even be able to submit main. In fact, you're just going to have to submit your other, your header file and your, what's the other file? The implementation file, the .cpp. So I'll be able to prevent you guys from just couting the output there. But for this assignment, I'll be going through each of your programs just to make sure that you didn't do one big cout. All right, so that's it. Do you have any questions? Once again, if you have problems with this, just come talk to me so I can help you, you know? I don't want people to be mad. I'm trying my best not to be mad. It does save us some time over here on our side, but I also know that there are some kind of annoying little features about it. All right, so just let me know so I can work with you. And that's that. And so once you get your points, it's good to go, and you've turned it in, you know. So that's CodeGrade. All right, that's CodeGrade. Make sure. Now, Christine has your other assignments. Your assignment. Good old CodeGrade. Yeah, I'm not so sure about that. Christine has your assignment 4s. She's working on those today, I think. So you should have those grades back very shortly. Today I'm going to speed run templates, and then I'm going to give you your tiny little assignment sometime today or tomorrow. And that's that. Templates is a really small thing. I guess I should take 15 or so minutes. Has anyone gotten to look at the operator overloading assignment, or should we wait until tomorrow or maybe the day after to look at some functions or some operators? So yeah, let me ask you that. For those of you who did take a look at the operator overload assignment, or for those of you who haven't had the chance, would you prefer that today we pick some operators, or should I push it? Tomorrow? Yeah, that's fine. I think tomorrow would be fine. Cool. I'm happy with that. Thank you for the feedback. Yeah, no worries about that. Should be okay. Assignment 5 is due tomorrow night, I think, and I do give you a late deadline for that as well. All right, but once again, assignment 5, for those of you who've done it, I think can confirm that it wasn't that bad, as long as, you know, you kind of paid attention to my dynamic array chat, you know, found the code and stuff like that. So, but cool. Thank you all. I'll check back tomorrow to see how we're doing. And that being said, I'm really not going to review the operator overloads because yesterday we didn't do too many more notes, right? We just kind of did some big examples. There's one thing I did forget to do. Yeah, you pretty much gave the solution. I did, right? You guys can't be mad at me at all. Pretty much. I mean, you had to change a few things for sure, but yeah. And you have to do the virtual part, right? The virtual part is on your own, pretty much. And that's kind of the most important part of that assignment, is understanding how to use the pointers and just making your classes virtual. So, you know, even if I did pretty much give you the solution, you should at least understand a little bit of about what's going on there. That was the goal. Yesterday was a hectic day for me, and I forgot to do the class code. I did upload the video, but I think I forgot to do the class code. So let me go ahead and put that up real quick for you guys so you can see it. 2800. Yeah. Well, so I'll tell you, I've taught this class quite a few times. And one thing that's different about this summer session compared to the other ones I've taught is all of the assignments are made by me. There have been some semesters where kind of the assignments come from all of the instructors, but since there's only 2 CS202 instructors for the summer, and I'm the one doing the very first session, every assignment is made by me, and I have all of the experience from the previous assignments. And there was 2 semesters ago where they did virtuals. And there was a triple pointer in there. And I didn't really cover it too well, and it was a nightmare for everybody. So it was just a nightmare for everybody. So I figured, you know, I could just you know, pretty much give you the code for that. But I did talk a lot about it, you know. You did get the notes and stuff. So this is what we did yesterday. I just want to make sure we did our pluses. If you guys wanted to do something for fun, there's the multiplication. Yeah, that looks up to date. So let me put that up there. And let me put up these notes. Did I save them yesterday? Yes, I did. All right, so that's all good to go. All right, so now it's time for templates. Templates. Let me open up VS Code here. So, templates. We're going to start today with just a small definition, some kind of a term that I want to talk about. And I'll also tell you while I'm at it, do you guys remember from assignment 4, the very first comprehension question, I asked you, why do you think C++ lets you allocate arrays of size 0 and size 1? And so what I'm about to talk about ties into that. So let's go ahead and get started. Let me get a big zoom in here. Oops. All right, that should be nice and large. All right. So to begin, like I said, this definition, I'm going to talk about just this word generic or general. Now, if I had to summarize my favorite thing in computer science, it's probably this word, generic or general. And so sometimes you kind of hear the quote that the simplest solution is always the best. Now, that's not always true. All right, but almost always. I'll put almost always. And that kind of ties into something being generic or general. So the term general means, at least in computer science, it applies to many cases. So the opposite of general might be, do you guys have an idea? Actually, I want to know what you guys think, if I'm making sense. Does anyone want to take a stab at what word you would... That's exactly right. Yes, yeah, that's exactly right. The opposite of general is specific. And so I want you to think back to assignment 4 when I asked you why you think C++ might let you allocate these dynamic arrays of size 1 and 0. So I would say, you know, pretend you're making a dynamic array class, all right? We've already kind of done that, right? That's what the strings class is, essentially. The strings class is a dynamic array of characters. The vector class, for example, is also a dynamic array. And imagine for every single member function, you code all of the code for the dynamic array, but then you have to go out of your way to code specific cases for when the size of the array is 0 and for when the size of the array is 1. So whenever someone calls insert, you're going to have like 3 if statements to check for, if it's going to be a size 1, if it's going to be a size 0, whether or not you have to call delete with or without the brackets, things like that. And so the cases for 0 and 1 I would call specific. And so things that are general happen to be nicer and better, usually. Sometimes you have to get specific, but... so that's all I really wanted to mention. And so templates are a way to be general. So it is a type of polymorphism. All right. For classes and functions. So we ask, what is a template? Well, let me tell you. This is a function or class that is equipped to deal with multiple types. Now I'm just going to ask this little question here, which I just want to know. Some of you might be familiar with enough with C++ at this point to know this. We have worked with one class before that is a template class. Do you guys know which one it is? I promise you that we've worked with one. I promise you we've worked with one. And if you don't know, it's not a big deal. I just want to see if you recall. Now I'm going to provide you this link here for polymorphism if you ever want to go take a look at it. Aha! Actually, 420 got it, and Coda got it. The vector is a template. The vector is a template class. And the identifier for that is whenever you declare it, you are specifying the type here. You remember this? That's something you've never done before, right? You've never really done that before, and that's why the vector was so interesting. Because you put in the type there. So a vector is a template. Very nice job. And so we're learning how to do this today. How we actually code something like that. So, what do templates do? Well, it allows one block of code to deal with many different types. All right. So instead of, do you remember during the function overload portion where we declared 4 functions? I think I called them add, and we added 2 ints, an int and a float and an int and a float and a float. And it was 4 functions with pretty much the exact same body of code. Well, here you go. We have templates now. So instead of doing a bunch of function overloads, we can use a template. So a really good example of something that you would want to make a template is sorting. So I'm going to kind of copy paste this one in here. Sorting is, you almost, in C++, when it comes to common algorithms that you use every day, sorting is going to be one of them. Now, I haven't taught any other sorting algorithms. Almost all of you know bubble sort. Some of you know insertion sort. And I think that's about it. You may have learned some other sorting algorithms in CS135, but when you get to CS302, you should learn the most effective sorting algorithm called quicksort. And so there are more efficient sorting algorithms out there. Selection sort, some of you might know too. But there's the most efficient sorting algorithm is called quicksort, and you'll learn about that in later classes. So I promise there's more efficient ones out there. But since you're always sorting something, you can kind of write a single sort function to be able to sort strings. I guess you don't know what this is, but maybe an Olympic event. You know, matrix 2x2, anything really like that. So we just code one sorting function, and it can handle all sorts of stuff. So we're going to talk about the syntax real quick. Let's see here. All right, so we're going to start with functions for functions. We're going to start with functions. So for a function, there's really only two ways you can do it. Well, before I get into that, I should talk about the general syntax of it. Looking at my notes here from last year, I want to make them better. So if we're going to talk about this general syntax of a template for anything, above your function or class, you will include this. Now it looks like this. You're going to put template, and then in the template you're going to give things a type name, and then you'll name it. So for example, type 1, and I'll get into the specifics of this, but this is going to be just to begin for a single template. And then you can actually have multiple templates. So once again, I'll get into that. But when you're going to specify that something is a template, this type 1 type can be any type. This type 1 type can be any type. So if you pass a string to this, this type 1 is going to take place of type 1. If you pass an integer, it's going to take place of type 1. So that's kind of where the template part comes in. And so there's kind of two ways for this. So for functions, if the template type is included in your parameters, you can call the function as you would any other function. So what does that mean? Well, a good example of that is, let's say, well, I'll just give you some general stuff. Say you have an int x1, and let's say you have a string s1, and you can just call that function, say, call template function. And the point that I'm making here is that the template type is included in your parameters. So what do I mean by that? Well, I mean that, say this, let's say this template function here is an int type. And in here, you see type 1 param. All right. So like I said, I'm going to go over the syntax for this shortly. But I set up here that if you want to make something a template, you're going to include pretty much this line of code above your function or class. So here's our function header, right? Int template function. And then right above it, I've got this template specification. And notice that type 1 is included in the parameters. So that's exactly what I'm talking about. And so in that case, I can just call it like a normal function. So x1, that will work. I can also pass an s1. That will also work. So notice that when you call this, kind of like a function overload, the computer is going to be able to tell, or the compiler is going to be able to tell which version of this template you would like to call. Oh, you would like this to work on ints, or oh, you would like this to work on strings. And that's because it's included in the parameters. Now there's another way you can call these for example, if the template type is not included in the parameters. Now I want to see with your knowledge of how vectors work, how might this code look if the template type was not included in the parameters. So if you're thinking back to vectors, how do you think the function call might look? So I'm going to do kind of an overload here. If in here we've got type 1 my variable, right, and then some code, notice that the type 1 is not included in the parameters here. It's not included in the parameters. So when I call it like this, it cannot tell what I want it to be. If I pass in an integer, it'll call this version in which I have, say, maybe an int. But within this, I have the type 1, and it can't tell what I want it to be. And so I'm going to call it like kind of like I would with the vectors. Well, maybe I'm being a little confusing here. So I would call it like this. And this is going to take us in to our classes discussion. All right. So if the template type is not within the parameters, then we're going to have to tell it specifically what I want that type to be. And so that's how it works with our vector, right? That's how it works with our vector. And this is how it works with all classes. So that's the next thing we're going to talk about. I know this is a little bit much. I'm kind of coding in the notepad, which I know, pretty colors in VS Code kind of helps you see what's going on. But for now, we're just kind of getting some notes down. So, stop me if you need, so I can talk about it. But we're actually just kind of wrapping up the notes here real quick. And we'll be coding before you know it. Classes is much simpler than what I just told you about the functions. So the template type, so for example, to start, well, let me just make sure here. So at this point that we're going to include that part. So I'm not going to type that back down, but I will give you an example. So the main thing about this is for a class, the template type has to be some sort of member in your class. So this is kind of, you can fluctuate it here. Maybe the return type of a function, perhaps a variable, a member variable. All right, so those are like your two options, or maybe even a variable within a member function's body. Member function's body. All right, so those are kind of your options. So if your class is a template class, the template type, I gotta fix that, has to be some sort of member in your class. Otherwise, there's no point to do the template. So I'll give you just some examples of that. So as I said, if you're going to be doing a template, you have to include this line of code directly above either the function or the class that you're working with. And then you're going to have a class, my class. And in here are your three options. Let's make, say, some private members, maybe some public members. So in order for this to work, you need, say, type 1, my variable. All right. So notice that the type 1 here is corresponding to this type. If you're not going to have that, you could have a return some function. We'll call it, say, foo. All right, with some code in it. Or you could have some function foo1 And within that function, you are referring to something called type1 myvar2, something like that. All right. So those are your three options. If you're going to do a template class, it either has to be, this is usually the case, by the way. So for example, in a vector class, which we've used plenty of times before, we have something like this. Type1, it's a pointer array. That's how your vector works. It has a pointer as a private member, and it's template. And it's a pointer because it's an array, right? So whenever you call pushback, it makes this array bigger, and the pointer is a template. So that's how your vector works. So that pretty much covers that. So I'll give you an example, right? And you guys at this point don't really need the example because you've seen it before, right? You always have to, let me get some notes here, actually. You always have to include the template type upon object instantiation. Let's Google check our word real quick here. Ha! It worked. All right. So that means, you know, if I'm in main, I'm going to declare a vector string, right? If I don't have this part, the compiler goes, what's the template type? Can you please tell me what is the template type? And you'll say, I don't know. So you have to do this. It's a requirement. So you might have int here, vec1, or you might even have vector Olympic. This is what we dealt with, right? You remember that? That's what we dealt with. Olympic event, vec2. In assignment 1, we had vector of Olympic events. All right, so that's it for classes. So we're going to give you some additional notes, and then I'll give you the general syntax, and we're going to be on our way coding. So you can use the keyword type name or class. All right, let me kind of put these in quotes here. I want them to stick out. To specify your template types. So what do I mean by that? Well, I mean that type name or class is interchangeable. So I'll say, in other words, type name and class are interchangeable. Ugh. And so, like I said, what I mean by that, well, if you have either a template type name type 1, or you can have template class type 1. All right. Now, I much prefer this one. You'll see me use this one most often. In my example today, I'm going to throw both of them in there just to show you that they are interchangeable. Because some of you do look at that class code and you're going to want to see that. But you can use either one. And I usually gravitate towards this one the most. All right. This one bugs me a little bit because ints are not classes, yet I can declare a vector for ints, right? An int is not a class, right? So this confuses me just a little bit, but if you're okay with it, you can run with it. So also, the type names follow the same naming convention as classes, variables, functions, roughly, right? So what does that mean? Well, you can use letters, numbers. Only use numbers if it is not the first character. Underscores, right? So you shouldn't be able to throw you shouldn't be able to throw like a plus in there or something. Letters, numbers, underscores, pretty much. And this one's very important. So this note right here applies to test question, all right? So I always ask these types of questions on my test, and you'll see me point it out today, especially in the example, but I am going to include it as a note. So I'm going to speak in kind of theoretical terms here. So I'm going to say for any operator O, that's an O, for any operator O, for any operator O that is used in the template function, let's see how I worded this. If the template is used with a user-defined class, such as Olympic event, so when I say user-defined class, talking about Olympic event, right? Or our matrix 2x2 class, or our CS 202 string class. I'm going to call it class A to give it a name. Class A must have operator O overloaded. All right, so I'm going to point that out today. Okay. Come back. Oh, geez. We should be good now. Are we good? Type 1 in the chat. 1 in the chat if you can see and hear me, please. That was just my little computer hiccup. You know. My computer always has a little hiccup. But the connection seems good today. So hopefully that's our own little hiccup. Thank you. That's our only little hiccup for today. All right, thank you. So let me scroll down here. All right, so I'm going to repeat this because I just kind of finished wording it. But for any operator O that is used in the template function, if the template is used with a user-defined class A must have operator O overloaded. So for example, sorting using the less than operator. All right, sorting using the less than operator. So at some point in your class, you're going to say if, let's say array located at j is less than array located at j plus 1, right? And that's when you're going to choose to swap. Now, let's pretend these arrays are for Olympic events. Now, in assignment 1, we never overloaded this operator for the Olympic event. So if we decide that we're going to call sort on a vector or an array of Olympic events, this is going to break your code. So that's what I'm talking about when I say that sentence. So operator O, in this case, is this. It's the less than. And then class A would be the Olympic event. All right. We've got 2 more notes here, and then we're pretty much done. So what's the next thing we got to talk about? for, well, we'll just say, to initialize a template type to a default value, how do we do it? Well, usually we use a constructor for that, right? Usually we use a constructor for that. Essentially the default constructor. And if that's the case, I want to ask the class, let's pretend I've got type name type 1. What do you think the default constructor for that looks like? If I wanted to call the default constructor for type 1, how do I call it? What does it look like? Let's say void my function. I'm not sure. Maybe we'll just do int x. And I'll say type 1, my variable is equal to what? What's it equal to? What do you guys think? This is just like any other type, right? What's our default constructor for the string CS202 class? What's our default constructor for the matrix 2x2 class, right? It's just the name of it, right? So if I wanted to initialize this to be a default value, I'll just do this. All right, so in the assignment, I might ask you to do that. Initialize your template variable to be equal to a default value. What do? You call the default constructor type 1. Let me fix this. Now, there's kind of a little bit of confusion here in that if this happens to be a class, if this is an Olympic event, your default constructor will be called already by default. But if I'm going to call my func with an integer, integers do not have, integers are not classes, right? So if I put type 1 here, it's going to make that integer be 0, basically. If I'm using a float, an integer, a short, maybe a character, those are all types that are not classes. This will still initialize them to be a default value, which will be it'll be 0, 0.0, maybe null character. So hopefully you understand this part. And that's why we're doing this, right? If I had just declared it like this, like I said, if I just declared it like this, the default constructor would be called for all classes here. But if it happens to be an int, we're going to want to put that equal type 1 there. All right. Call constructor default. And the last little bit, a little annoying bit. If we are using a template class for any member functions defined, and when I say defined, with their bodies, I'll put the parentheses there, defined outside of the class, which means bodies are outside of the class. The template header must come with the function header. All right, so that's kind of annoying. I'll give you an example of that, but that just means if we've got a class A in here, now this class A is going to be dealing with a template type. So if I want to do that, I'm going to type template, type name, let's say T, and then in here I'm going to have, say, some function T foo constant, and notice that this is just the prototype for that. So then when I go outside of the class, now I'm outside of the class, I need to do this little bit. I need to come up here, I need to grab this thing. At this point I could rename it. I'm not going to get into that yet, but you could rename it if you wanted to. And then you're going to type T, and then you're going to type a foo constant body. All right. So I'm not going to spend too much time on that. I think it's best if I just show you that in the code. But at least you have it there in the notes. And finally, I'm just going to give you the basic syntax for this. So you can reference this if you want. Before I do that, let me just say one more note. Any function or class can have any number of template types greater than or equal to 1. All right. And so what does that look like if we wanted to do it? Well, you would just say template type name T1, type name T2, ... continues on. All right. So that's our notes. That's it. No more notes at all. Unless I run into something during the example. So we're done with notes. All right. So if you need me to go back, let me know. These are our template notes. And we've got about 40 minutes or so to get started on some template examples. So we're going to start with a basic one. We're going to just start with functions, all right? We're going to do the sorting thing. So I'm just going to sort some stuff. So here we are in my templates.cpp. While we're waiting, let me make sure that Bobby will be alive and ready when I come back to it. I need my favorite things in here using std, and then we're just going to start with int main turn 0. So I'm going to declare a template sort function. Template sort. It'll be bubble sort, all right, because that's the only sort I use in this class. I'm sure some other computer science professors would be appalled to hear that, but I only use bubble sort in this class. So, what's the first thing we need? Can anyone give me, what's the first thing we need for our function? Type it in the chat, and I'll go with whatever name you give me. What's the first thing that we need? I'm doing a function here, all right? Not a class, just a function. Take your best guess. This is a learning experience. Take your best guess. I'm going to wait. We're making a template. There you go. Thank you. Yep. Template. Type name, right? Or I could use class. All right. Once again, interchangeable. Type name. And then you wanted to name it that. So that's our type name. I think everyone's a little bit lag. Do you mean like lagged behind, or it's all choppy? I don't think it's choppy. I think the connection's good. But I do think everyone's a little bit behind, and that's fine. All right. So our type name is bubsort here. So the way our bubble sort is going to work is just like any other bubble sort. It's probably going to be a void function, unless we want to return a copy of it, but we're not going to. And it's going to be called bubble sort. No, of course, I understand. I know many of you do participate. And I love to see you in the chat. And since it is delayed, I think it's pretty good for me to kind of stop and at least catch back up with you to kind of see where I'm at. Because chances are one of you might have a question, and next thing you know, I'm 5 minutes ahead, and it'll be a mess. It's not too bad. I think it's about 30 seconds or so, which isn't terrible. We can all wait 30 seconds. So we're going to do an array. All right. Now, since we've been doing pointers, I'm going to use a pointer. All right. I'm going to use a pointer. And so the way we'll do that is this. We'll call it. So we need a pointer to our template type. Right? So a pointer to our template type would look like this. Now notice that the type name is in the parameters. The type name is in the parameters. So I'll ask you while I'm going to type out the rest of it. If the type name is in the parameters, do I have to specify what type I'm going to be using on the call? For example, if I say bubble sort like this, do I have to do this part if this is in the parameters? What do you remember? Now, some of you guys like to do the prototypes up here, so I'm going to do it that way. So if I'm putting the definition down below main, I still have to bring this template with me. All right, that's a little bit of an annoying part. This comes with the header. It always comes with the header. And yes, the answer is no, right? I don't have to do this part. So if I'm going to call it, I can just pass in my stuff. All right, but we'll get to that. So I'm down here, and what does bubble sort look like? Well, we've got for int I is equal to 0. I is less than the size minus 1. I plus plus. And then we're going to do another for loop here. For int j is equal to 0. J is less than size minus I minus 1. J plus plus. And then in here, we're going to do if array located at j is less than array located at j plus 1. Then we'll do our swap. Now guess what? We're swapping the template type, right? So you're going to do bub sort temp is equal to array at j. Array at j is equal to array at j plus 1. And array at j plus 1 is equal to temp. All right, should be nothing new here. This is a little large, so I'm maybe going to shrink it down just a tidge. But that's our bubble sort, right? I'll add some comments. I always like to add some comments. I got to add a bracket there, too. So that should turn green now. Please change colors. Why won't you do it? That's fine. So notice our template type is there, right? And that's because this array is of type this. So now I'm going to call this with a few lists, and then I'm going to break my code, all right? I'm going to break the code. So let's make a few dynamic arrays, all right? We're going to make a few dynamic arrays. Now I'm going to do it the easy way, not the hard way, all right? I'm going to do it the easy way. So I'm going to make an int array, maybe say 5 is equal to, I don't know, let's say 2, 3, I meant to say 2, 67, -1, -2, 99, 7. Maybe I'll make it a little bigger. So that's going to be our integer array. Now I'll make another one. Let's do a car array. Let's do a string array. And in the car array, we'll do I don't know, maybe null character, maybe dash. Now these are going to be sorting off the ASCII values, okay? Sorting off the ASCII values. So don't get concerned here with what's about to happen. Z. All right. So that's our character. And then we'll do every cat I've ever had in my life. Probably going to scare you guys away. I promise I am a crazy cat man. We had PETA. We had Willa. And we had a Mary Ann. All right. So those are all of our lists. I'm going to make a little vertical here so I can see it. Diva. There we go. All right, so those are our lists. So I'm just going to do a few for loops down here because I want to print them out. For int I is equal to 0. I want my size maybe. I don't want any magic numbers here, right? Is equal to 6. So if I do I equals 0, I is less than the size, I plus plus, I'm going to see out whatever our... Actually, let's do a template one. Let's do a template function for fun. Let's do another one. Please stop me if I'm losing you. All right, please stop me if I'm losing you. If I am losing you. So this one I'm going to call maybe class. I just want to show you that they're interchangeable. And I'll call it T1. I usually go type 1, type 2, type 3, T1, T2, T3. That's usually what I do. And we're going to have a void print array. And in here, we're going to have a T1 array, just like we did up there. And we're going to have an int size. And I'll do the thing down here. So I'm going to copy it, bring it down to the bottom. I'm going to open this up. I'm going to do that. I'm going to do that. And in here, I'm going to see out array located at I, and then I'm going to maybe put a space there. Comma. No, I'm not. I'm going to make this fancy. If I is less than size minus 1, I'm going to make a fancy one. All right, so there's our template print array, all right? So, I'm going to do that. I'm going to do that now. So we're going to do print array. We're going to pass in our int array and the size. Right, and then I will call bubble sort on our int array. I'm going to pass it the size. And then I can do this for literally every array that we have. See out this. All right, folks, so let's give it a shot. I want this to be my car array. I guess I want to print it afterwards too. I don't know what I'm getting at here. And then I want this to be my string array. All right, so we're about to run some code. I'm just going to refresh you guys on what I just did in case I went way too fast. So we made 2 templates, right? We made a template for bubble sort and template for printing arrays. All right. And then in main here, I declared 3 arrays, right? One for ints, one for characters, and one for strings. And then what I'm going to do is I'm going to print each array. I'm going to sort each array, and then I'm going to print it after it's been sorted. All right. Now, just like you've always done in CS135, I'm putting the definitions for these functions down below main. So there's one option, and there's 2 options, right? So let's see if Bobby is awake. Yes, it is. So I'm going to super zoom, and I'm going to grab this code and put it here. And I'm going to G++ this. It's just going to be called templates. And it looks like I had one small little error there, and that's fine because this is not called SZ, but it is called size. So let's try it one more time. All right, and let's give it a run here. /a.out. All right, And there you have it, folks. There you have it. So, here's our array, right? We printed it using a template function. It handled it, no problem. And then it sorted it. Looks like from largest, least, or greatest to leastest. Same thing here. There's a null character there. And then it sorted my list of cats, right? So we've got Willa, Peta, Patty, Marianne, Loaf, Diva. So it works, all right? Now, before we move on from this example, do you guys remember what I said about the operators? Do you guys remember that? So I'm going to reread it, and then I'm going to ask you some questions, all right? I'm going to reread it, and I'm going to ask you some questions. So, what am I rereading here? Well, it looks like it's going to be where is it? This bit. For any operator O that is used in the template function, if the template is used with a user-defined class A must have operator O overloaded. So, do you guys foresee any, do you guys see any operators in this function, and which operator do you see? And of course, the operator must apply to the template type. The operator must apply, the operator must be working with the template types. So I see some, for example, I see some i's up here, I less than size. These are ints, right? We don't have to worry about that. But yeah, Synchro, you got it, right? This is bub sort here, right? This is our type. So guess what? This code is not guaranteed to work. And I'll break it. I'll show you. I'll show you. Oh, that's a great one too. Coda and 420, you are right. All right, you guys are totally correct. They are totally correct, right? Totally correct. Now, guess what? The assignment operator is handled by the compiler automatically. So, if the class contains a pointer, then you're going to have some problems, right? If the class contains a pointer, you're going to get memory leaks here. You're going to get aliasing and memory leaks if the assignment operator is not overloaded. So I'll take both of those as an answer. But here's the thing to note. This will break your code literally. This will break your code's memory. So this should prevent compilation. So I think if this one will not allow your program to compile, this one will allow your program to compile, but there will be memory problems. So let me break the code here. So up here I'm going to make a class point 2D. We've done this one millions of times. In here I might just say private int x equals 0, y equals 0, public, I don't know, point. Really doesn't matter too much what I have in here, as long as it's some code. Probably x, comma, y. All right. So here's what I'll do. In here I'll make just an array of print points. Point 2Ds, actually, point 2D, P2D array. Let's just make it say 3 big, and it's going to be equal to, let me just call the default constructor, which we didn't make, but the compiler will make for us. So I'll do that. And then I'll actually just kind of comment this little bit out for just a moment. And I'm going to try to call these template functions using this class. Now recall, there is no less than in here. And this one doesn't contain a pointer, so I'm not going to worry about the equality, but I'll say potentially assignment op problems. All right. So let me break the code. So I should see compiler errors. I'm gonna make it real small because otherwise the errors won't be formatted nicely. I think. Oh! Aren't these fun? I know you guys have seen this error before. Look at how many. Oh man. All right, let me ask this question real quick. What about this one? Do you guys foresee any operator problems in this one? And if so, which one? Which operator is it? Which operator is it? What's going wrong in here? Yes, that's right. Nice job, 420. And attacker, nice job. Right, this one. So actually, I'm going to be able to go through this code and find them. So notice here, I know you guys have seen this before. I know you've seen this error before. Do you know how you generate that error? That's when you were doing your assignment 1. That's when you were doing your assignment 1, and you would say Olympic event, my event, and then you would say cout my event. That's how you make that error. Why do you see that error? Because this operator is not defined for Olympic events. So whenever you see that error, that means that there's an operator that needs to be fixed. So if you look at it, you can find it. You can find it in this mess. In this mess of words. Where is it? All right, problem number 1. I found it, all right? It's telling you this, no match. It says no match for operator. I'm not going to finish out the sentence here, but this OPE thing, it says no match for operator. If I keep scrolling, here it's telling you about all of its, here it's telling you this operator's life story. More about the operator's life story. Here's all of the operator's overloads. Look at all of its overloads. This operator will take iOS base. It'll take a long. It'll take an unsigned long. It'll take a bool. Wow. It'll take a short. This is amazing. It's telling you its life story here. It'll take doubles and floats. Long doubles, const void pointers. Wow. So you keep scrolling. You keep scrolling. And there's the new one, right? Here's the next one. All right. So when you see that error, that means there's an operator that is not overloaded, okay? So that's important. That's a test question. I'll always ask that one. I'll say, is this code guaranteed to work? Or I'll say, is this code guaranteed to compile? Is this code guaranteed to work without memory errors? Something like that. And you'll say, no, there's a less than operator in that function. All right. So that's our example 1. So now I'm going to go into my second example. We may finish it today. We may not. We may take just a few minutes tomorrow to finish up our template talk. So if you guys are having questions after or during this next example, please let me know. So what we did was functions. So now I'm going to do a class for you. I'm going to do a class, and I'm going to do a class with multiple template types. Okay, so we're going to do pretty much the only 2 other options you have. I guess while I'm in here, well, we're not going to worry about it. There's a whole bunch of stuff you can do with C++. I'm not going to worry about it today. We've only got so much time. Templates 1. All right, so I'm going to grab my favorite stuff. And And here's more of my favorite stuff. So we're going to do some template classes, all right? So the first one we'll start with is just maybe a container, just a container. So what's our class? I think I've done that for you. It goes, aren't templates so much fun? They're amazing. Yeah, so that here, if I didn't make my point, whenever you code bubble sort, right, for your arrays, you need one for strings, you need one for ints, chars, doubles, floats. You have to declare all of them. But now, look, we only have one. We only have one function definition for all of the types there ever were. And the only reason that the string one works is because the less than operator is overloaded for the string class. Just like the insertion operator is also overloaded for the string class, right? So templates are helpful for us. So the first thing I need is a template type, right? So this is going to be template type name T. I'll call it type 1. I just kind of want to do that. It is a shortcut. That's exactly what it is. It's a shortcut. Less time coding, more time, watching your favorite TV show. I don't know. In my case, petting cats or roller skating. That's something I do. Catch me at Skate Rock City on Sunday nights. That is the roller rink that Floyd Mayweather bought, by the way. Fun fact for you guys. So this is going to be our container class. And we're going to have a private variable, and we're going to have a public variable. Members, rather. And I just kind of say words sometimes. And just like any other container class we did before, I guess we did an int container class. This one is going to be a type 1 container class, right? Type 1 kind of cell, I guess I'll call it. I'll see you there. So that's going to be our cell, right? And then let's just make some things. A default constructor that, let's say, since this is a pointer, I can initialize it to be null pointer. That's fine. But let's make maybe another default constructor. And this one will just take a bool. And the bool will either be true or false. Called initialize. I don't know. Initialize. Init. How about that? I can spell initialize, I promise. Initialize. Did I spell it? I can do it, guys. I swear. And we'll kind of do a ternary. What do you say we do a ternary here? Well, no, the ternary won't work. I wish we could do a ternary, but no. So we'll say if it wants us to init, this this cell to contain something, we can say cell is equal to new type 1. This calls the default constructor. Else cell is equal to null pointer. All right, so that's going to be maybe another default constructor or kind of a default constructor that will allow us to put something inside of the cell. And then finally, let's make a parameter constructor that will initialize this. What type will our parameter constructor take? Can anyone tell me? What type will our parameter constructor take? What type does it take? What type does it take? I know we're delayed, so I'm just waiting here. But you guys can do this. What type does it take? Nope. What am I doing here? What am I doing on this line? What type is the cell? It's a pointer to a type 1. So if I want to initialize it, what type does it take? It takes a type 1. Are you okay with that? This is, the container is going to hold anything. The container can hold an int, a string. It can hold an Olympic event. And so if we want to initialize it to hold something, then I'll just do that. So this is going to be, I don't know, this is going to be like a semi-default. Semi-default. We'll call it like a, the init constructor. Can you initialize it to be something? Hello. I don't know if you guys can hear that. That's Patty saying hello. And then we have our default constructor. You want to say hi, everybody? Say hello. Say hello. Doesn't like that very much. All right, get out of here. You said hi. So, those are our constructors. Those are our constructors. Notice here there's an assignment op. There's an assignment operator there. Take notes, right? There's an assignment operator happening here. Potential problems. And then what else do we want to do? Well, we'll start with that, I think. We'll start with that, because we are kind of running out of time. Maybe we'll do one member function. We'll do a getter. We'll call it the get item or something. So this is going to be, what type does it return? If we're going to get the item, it's going to return a type 1. Get item. And it can be constant. And in here, we're going to check a few things. First, we'll say if our cell is not empty, right? If our cell does not equal null pointer, then we can return the cell that's dereferenced. Else, we'll just return maybe a default version of type 1. And we'll say, oh, hey, this is empty. 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 I'm sorry if I blew in the mic there. I got cat hair on my desk. All right, so let's kind of declare these. Now, let's say I wanted a container for an int. Can anyone tell me what the declaration for that looks like? If I want a container for an int, what does the declaration look like? We're coming up here on the end of class, so let's make it. We've got 7 minutes left in us. I know we can do it. If you need a hint, what does the vector look like? If this is a class and it's a template class, how do we declare it? What does the vector look like when we declare it? I don't know why the chat, I don't know why it censored that. I think you guys can see it though, right? Let me check my mod. I'm gonna say no. No to that one. If we're gonna declare a vector for ints, say named vec, how do we type it? I know one of you can get this. If I want a vector of ints, call it vector vec. Yeah, there we go. Attacker got it, right? That's what I'm looking for. That's what I'm looking for. That's what I'm looking for. Right? Does that make sense? Does that make sense? And if I want to initialize it, I can pass in, say, a 3 or something. That calls a constructor. I could pass in true if I wanted to. That calls a constructor. So let's pass in true. Let's see what it initializes this to be. So I'll call it cout int container dot get item. And I should see a 0. That's what I plan on seeing. I should see a 0. And the reason for that is because, and I'll show you here on the code. Hello. I'll show you here on the code that we initialized it to a default value, right? So if we did ints, I should see a 0. Templates 1. There it is. All right. And so pretty much I can just make endless containers now, as long as I'm equipped to deal with the types, right? So we'll do one more, I guess. Let's call this one, I don't know, add items. Do you remember we kind of did that for our containers a while back? So let's call this a static one. And I actually wanted to return a container. Now this is very important. It's going to return a container of this type. It's going to return a container of this type. So we're going to say add containers or something. Now it's enough to do this. I promise you, it should be enough to do this. So let me try this. I'm just going to do some compilation stuff here. I'm just going to do some compilation stuff here. Oh, I forgot a bunch of stuff, right? There's a pointer in here, right? So we have to do the rule of 3. What am I doing? It works like any other container, of course. Or any other array, any other pointer, I mean to say. If cell does not equal our null pointer, delete the cell. We're probably going to do a copy constructor. What does that look like? Well, that looks like container, const container. And actually, we're going to get it done this way. So I'll come back to the static part in just a little bit. But I want to show you this. I want to show you how this works here. So I'm going to speed run this one. All right, I'm going to speed run this one. So I'm just going to say if the copy dot cell equals null pointer, actually, let's do our fun little trick. What do I do for the trick? If I want to do the trick in here, tell me. I'm still gonna save this code here. But if I want to do the trick, what do I put inside of the copy constructor? What's the trick code? Oh, we're running out of time here, guys. So we'll come back. But tell me, before we go, what's the trick code? And then I'll end the day. And we'll come back to this tomorrow. We need to. I'm kind of rushing here at the end. And I don't want to do that. We still have a little bit of templates to go over, and that's fine. So we'll continue tomorrow. But yeah, that's right. Attacker got it. Right. So there's the trick. Fun trick. Easy trick. Easy peasy trick. And then I'll finish this up tomorrow, and I'll stop rushing. I'll let you guys go. So at this time, do you guys have any questions kind of about what we talked about today? I I will upload the code in the notes. You can always message me if you want. Tomorrow, if you have time, or tonight if you have time, why don't you take a look at that assignment 6 and just think if there's any operators you want me to do tomorrow. So tomorrow we'll start with the operators and then we'll finish up templates. Don't do that to me. I didn't tell you to go roller skating. Oh, you gonna sue me? I don't think that's... Man, I can't have any fun with you guys. I can't have any fun with you guys. Teacher told me to get a cat. I'm allergic. Oh, I only tell you how to code. Oh well. So, I hope you guys had a good time today. I hope you followed a little bit about what I said. If not, you can always talk to me. I'll do my best to help you out. Thank you for coming to class today, and I'll see you guys tomorrow. I hope you have a wonderful day, as always. You're welcome. Have a good one. Thank you. You're welcome. You're welcome. Thank you and thank you. I'll see you guys next time.